Number 43. If a wind instrument such as a tuba has a fundamental frequency of 32 Hertz, what are its first three overtones? It is closed at one end. All right, check out number 42. I went through a brief discussion about all the formulas here, open at both ends, and closed at one end. So we're going to use the formula for a tube here, closed at one end. It's going to be that the frequency of the nth harmonic will be equal to the harmonic n multiplied by the velocity of sound divided by then 4 times the length of the tube. And the harmonics here can be either the first harmonic, the third harmonic, the fifth harmonic, the et cetera, et cetera, et cetera. Okay? So now, in this particular case, we have to find the first three overtones. So remember, the first harmonic here, number 1, is always the fundamental frequency. Fundamental frequency. And then the overtones are every harmonic after that. All right, so for example, they want us to find the first three overtones. So that means that 3 represents the first. I'll just call it O for overtone. 5 will represent the second. And then guess what the third is? We just got to write it in, 7. Okay? You see the pattern there. So this is the third overtone. Okay? So now, all we need to do is basically just plug it in, right? So it wants to know what are the first three overtones. So basically, well, it's a little more complicated. It's slightly more complicated than just plugging it in. But what we realize here, actually, it's really not. So what we realize is that if I know the fundamental frequency, okay, which they told that to us, right? It's 32 Hertz. So this is 32. What I could do then is solve for, I could solve for this unknown piece, right? We don't know the velocity of sound, nor do we know the length of the tube. So you could solve for this, right? We could just call this a big ol' X. And obviously 32 times 1x is just 32 is equal to then that X value, right? So this X represents this whole thing. But remember that the velocity of sound is not going to be changing, and the length of the tuba is not going to be changing either. So this is like a constant, right? So now when I do, let's say, find the next harmonic, find the first overtone, which would be the next harmonic, what I would now do is say the frequency of the third harmonic, okay, because the third harmonic correlates with the first overtone, right? That's going to be equal to now the third harmonic 3, that's the n value, multiplied then by this VW over 4L, which we don't, which we do know. Right? Remember, we didn't know the exact values here, but we know that that whole fraction has to be 32. We just found it before. So you can just plug in 32 here. And look at how nice this is, right? So the the frequency of the third harmonic, which is the first overtone, is going to be simply 3 multiplied by 32, aka 96 Hertz. So if you notice, right, we can come up with an even nicer formula here, another formula that is really simple, and I'll probably refer back to this one, that I could say this, that the frequency, okay, of the nth harmonic will be equal to n multiplied by the fundamental frequency. This formula, okay? That'll always work, okay? So now basically if I want to find the second overtone, we know since it's a tube closed at one end that that's really the fifth harmonic. Okay, so this will be frequency of the fifth harmonic will be equal to 5 multiplied by that fundamental frequency of 32, right? So all we got to do is just a little math here. So what does that work out to be? It looks like it's going to work out to be 160, right? So that's in Hertz. Okay, great. And then, last but not least, we have the frequency of the seventh harmonic, which is the third overtone. That's going to be equal to 7 times 32. Oops. Times 32, right? And now let's just take care of that. Oops, 7. So that's going to be 221. Let me just double check that. 7 times 32, because you never know this early in the morning. Oh, 24. That's silly. Yep, like I said, this early in the morning, you never really know. You never know what you're doing. All right, so that takes care of that, guys, all right? So I appreciate it very much. Thank you for tuning in, and we'll see you soon. please remember to subscribe. Take care.